Okay, so example one here involves a new idea. It's called a tangent line, and sometimes students, we've done SOHCAHTOA with tangent, and then we have a circle with a tangent line. They have to use the same word to represent two different things, so don't get in your mind that this is the tangent we were working with SOHCAHTOA. What they're asking us is KJ, which is this segment here, tangent to circle P at J. So first off, the word tangent in relation to circles and segments or lines. A tangent line is described as a line or segment that would intersect a circle at exactly one point. That point it intersects at is called the point of tangency. So the question is asking if KJ is tangent to circle P at J. So if it is, then J is the only point that this segment would touch along that line. And figures aren't drawn to scale, so you can't make assumptions about things. It kind of looks like it maybe intersects more than one spot, but we'll just go with the assumption that it's possibly tangent. And again, just for vocabulary purposes, the place where it intersects the circle, if it is a tangent, would be called the point of tangency. So, in case I use these words to describe things, a tangent would be a line or segment that intersects a circle at one point. The point the tangent intersects the circle at is called the point of tangency. So, with that in mind, one property of circles and their tangents is a tangent of a circle is perpendicular to the radius of the circle at the point of tangency. So what this is saying then is, in order to determine this fact, whether or not this segment KJ is tangent to the circle, we have to ask ourselves if this angle right here is a right angle. So I'm going to put a right angle picture here. And again, figure not drawn to scale. It doesn't look like a right angle, but maybe it is. I'll put a little question mark there. Maybe it is, maybe it isn't. So the way we determine in math whether or not an angle is a right angle, when we know all the sides to the triangle, as you can see, the radius is PJ of 6. This radius also is 6. This little piece outside is 4. So that side there is 10. So if we combine these together, that whole side there is 10. If this is a right triangle, if this is a right angle, the longest side should be the hypotenuse, which 10 is the longest side. It's opposite what could be the right angle, so it's where it should be at least. And also, if it's a right triangle, then the Pythagorean Theorem would work. So the basic plan here is I'm going to apply the Pythagorean Theorem to these three sides, leg, leg, hypotenuse. And I'm going to question whether or not the sum of these two squares equals that square. So if we try that out, 9 squared plus 6 squared equals 10 squared. Maybe. Oops. Question mark in the wrong spot. Maybe. You got the question mark over the equal sign because we don't know this. If we square everything out, 9 squared is 81, 6 squared is 36, and 10 squared is 100, question mark. And finally, if I add 81 and 36 together, I get 117, which obviously is not the same as 100. So since the sum of the squares of these two sides does not equal that squared, this is not a right triangle, therefore that's not a right angle, therefore KJ is not tangent. So is KJ tangent to circle P at J? No.